Welcome back. Now that we have discussed the concept of what a limit is, let's do a problem and talk about the informal definition for the limit of a function. So in this problem, we have a function. We'll say the function is f, and then we have a and l being real numbers. And so what the idea here is we say as x takes value closer and closer, infinitely close, but not equal to that a value on both sides of a. So that's thinking about approaching from the left and the right. Then the corresponding values of the function get closer and closer and perhaps equal to, as we saw in that last example from the previous video, it was equal to some limit value L. All right, so that's the idea. And we have part 2 here. The value of the function f of x can be made as close to that limit L as possible, or as desired, by taking the values of x that are close enough to a. So then here we have our formal or informal, in a sense, limit definition. So then at that situation, the limit L represents the limit of the function as x approaches some predetermined a value. Okay, so that's the idea here. So let's do another problem. For this problem, we're going to find the limit as x approaches 2 of the function g of x. So in this case, my a value that was previously defined as 2, and my function is g of x. And g of x is defined by this rational function, x cubed minus 2x squared divided by the quantity x minus 2. As we mentioned in the last example, we can always try to plug that 2 value into the function to see what our output is. But of course, you can see if I take 2 and plug that into the denominator, I'm going to get an undefined value. So the function's not defined there. I can't just evaluate it. So how am I going to find the limit? Well, we have some different strategies. Of course, we can use the same strategy we used in the last video where we make a table. And if we make a table, we're going to look at values approaching 2 from the left and approaching 2 from the right. And as we approach from the left, we see our y values getting pretty close. I would round that, if my calculator gave me that, to 4. So 4 on the left, as well as 4 on the right. So even though the function is undefined at x equals 2, we might surmise that the limit is 4. Now, that's not exactly the most perfect way to do it, but it is certainly one way, full of brute force, plug and chug. So let's look at another way, maybe using algebra, which is what we're going to be relying on in this class. So if I think about using algebra, I'm going to take my function g of x equals, and again, we have x cubed minus 2x squared divided by the quantity x minus 2. I'm going to try and simplify this rational expression. Now, I can't do anything with my denominator, but I do notice I can factor a GCF of x squared from the numerator. So that leaves me with x squared times the quantity x minus 2. Now, I don't have parentheses around my denominator, but you should all recognize that those are common factors and cancel. So this function, g of x, reduces to the function x squared. So now we're left with solving the problem. The limit as x approaches 2, g of x, I've used algebra to reduce this or simplify the function to x squared. And in this situation, this is the same problem as we did in the previous video. I can plug 2 into x squared, and that's going to give me an output limit value of 4. So the limit as x approaches 2 of g of x equals 4. And of course, we can consider this graphically as well. So I'm going to come over here, I'm going to bring the graph of g of x in. And as I bring that in, if I were to graph this on my graphing calculator, I would get a parabola. What I might not see is that there is a hole, a removable discontinuity, which occurs at x equals 2. So even though I'm getting an undefined value, this graph we can see as x approaches 2 from the left, so traveling from the left side of x equals 2 towards that y value, we're getting close to but never equal to 4. And then the same thing approaching x equals 2 on the right, traveling from the right towards that y value. Again, we're approaching but never going to touch y equals 4. So what we've seen here is we have found another limit, the limit of this rational function g of x as x approaches 2. And we looked at solving this 3 ways. We can make a table of values, plug and chug, put in x values that are close to the point on either side and see if the y value seems to converge towards a similar number. Or you can try to simplify algebraically and plug in. That's what we're going to be doing most of the time. That's the kind of work I would expect to see on your test. And then also you can consider the graph. So take out your calculator and look at the graph and see what is happening at that x value. Where is the y value going? All right, so that's it for this video where we talked about the informal definition for the limit of a function. Please always know you can reach out, email me if you have any questions or concerns.